Hello and welcome back to another episode of Learning Java for Beginners, where we go from absolutely no knowledge of Java all the way up to building beautiful applications. This episode we're going to cover for loops and while loops, so it's going to be quite a quick episode. Hopefully we can power through this. They are really important, similar to if statements, apart from they loop, and they both are useful for different reasons, and we will get into both of them now. The first loop I want to cover is a for loop. So a for loop is good when you know the amount of times you want to iterate over something and then do an action that many of times. For example, I'm going to write some code here and we are going to break it down as usual, see what's happening, and then I might set you a challenge afterwards. So let's start off with integer x. We've used x too much. Let's say integer length of some counter. And we'll set that to 10. Okay. And then we're going to create a for loop. So the syntax for that looks like this. For integer I 0, I is less than length of some counter I plus plus. We then write a code block at the end here, and we do something within here, which we will do that in a minute. We can actually change this name here to amount of times we want to print. Okay, we'll just leave that for 10 and change this as well. Amount of times we want to print. So this for loop, what we are doing is saying for I equals 0. So what is this? We've seen this before. We are just basically creating a new variable in here. And it's always going to be an integer. The common practice is to call it I, and we are then going to assign it the value 0. So we are starting at 0. This is where we start. This is the conditional. So while I is less than 10, we will increment I. So it will go up. It will do this once, and then I will increase. So let's do something here and get like an output. So we can print. What we can do is we do system dot out dot print line, and then we are going to say this is printed. And then we're also going to say system dot out dot print line, and we are going to print I. Before I, we're going to say iteration like so. We'll just break this down in a second, don't worry. Okay, so what this is going to do is it's going to enter this loop, because this is the comparator here, as we've seen before. It's comparing these two values. So integer I is 0. This is set at the start of the loop. So once we enter this loop, this is set and it never does this again. So after the first time, it's set at 0 and then it increases every time. So it compares it and says if I is less than times we want to print, which is 10, then we're going to print some stuff. And then we're going to also increase it at the end. Okay, so the first time round, I will be 0. The second time round, it'll be 1, 2, 3, 4, 5, 6, 7, 8, 9. And it will stop at 9 because it will no longer be less than 10 when it reaches 10. And we will be able to see a visual representation of that right now. So 0, 1, 2, 3, 4, all the way up to 9. So it's printed out 10 things. Remember, we start at 0 in this kind of world. So I is 0 the first time round. It says this is printed, and then it prints out I. Then it goes back to the start of the loop and runs this comparator once again. Now, at the end of the loop, it will do I plus plus. We know what that does. We can say plus equals 1. This is do not do this. This is just bad practice. It's I plus plus. This is a traditional for loop, and so at the end here, it will say add 1 to I after we've run what's in the code block. Then it will come back to the comparator once it's added 1 to I, and it will compare it, and if it's true, it will print, and then add 1 again, and then compare it. If it's true, it will print, add 1 again. and so on and so forth. Um, this is a traditional for loop. There are other variations of for loops, which I will get into more when I cover how Java 8 changed things with streams and for each's and all kinds of stuff. This is still used. It's a little bit ugly in modern day, but this is a good learning point for how they work because it's quite visual and you can see how it works. When we get into streams and stuff later, they usually replace for loops where they can, and also there are like for each loops as well, which is a little bit nicer with objects and stuff. But this is the basic traditional for loop. Where this can start to get a little bit complicated is when we start getting nested for loops. Nested for loops are particularly useful in kind of two-dimensional thinking. You might come across them. They're good to know. You can have nested other things. You can have nested while loops, nested if loops, if statements. Sorry, amongst other things. So nesting is really important, and I think for loop demonstrates it quite well. But it's also quite a complex example to wrap your head around. And I think if you can get this, you can kind of understand nesting as a general. So what I'm going to do is I'm going to write out a nested for loop and trying to explain it and break it down for you as best I can. So first we're going to write it. So it's going to be for integer j equals 0. Again, j is another common nested variable name for these loops. J is less than amount of times we want to print j plus plus in here. And in here we can say system, if I could type system.out.println. In here we can say, in fact, let's name this to something different because, no, okay, we won't. We can say I is whatever, and j is whatever. Let's just make this a little bit nicer to see. And then, okay, let's break this down. So, the for loop starts here at the I for loop. So let's begin with that. The I for loop starts here at 0. As we know, it goes around the loop until it's done and it's reached 10, at which point it stops. So the first iteration of this, I is going to be 0. It's going to go into this code block here. It's going to hit this second for loop. Once it's hit the second for loop, it cannot leave the second for loop until this for loop's finished. What does that mean? So we hit here, we say j is equal to 0. Okay, j is less than the amount of times we want to print. Yes, it is. Okay, so we're going to print out. So the first iteration of this, we're expecting fully for it to be I is 0 and j is 0. Seems pretty simple. Once it's printed that out though, what it's going to do is it's going to reach in this code block, say, right, okay, what do I need to do now? It's going to increase j by 1. It's going to increment j by 1. J is then going to equal 1. J is still less than amount of times we want to print. Remember, we can't leave this j loop until it's finished. So this is still 0. We're still in this, but it's still 0. This is now 1, however. So we get in here, I should be 0, still, it's going to be, and j is 1. And again, I is 0, j is 2. I is 0, j is 3. And it will continue to do this all the way until j reaches 9. Once j reaches 9, it gets to the end. It'll increase j by 1, it gets to 10, and j will no longer be less than, which means we break out of this code block. We head back to the first code block, because remember, we're still in this for loop here. I is still 0, I is less than here, I plus plus. So we've completed this block, which means we reach the end of here, which means we hit an I plus plus. That means I is now 1. I is 1. Okay, we enter this code block, we again hit this for loop. So now it should print out another 10 prints saying I is 1 and j is anything from 0 to 9. So I is 1, j is 0, I is 1, j is 1, I is 1, j is 2, I is 1, j is 3, etc, etc. And it will continue to do this until we've got 100 results of every combination of the two letters possible numbers. So if we hit that out now, what we can see here is exactly what I said. We expect I to be 0 for at least 10. which it is. It's from 0 to 9. That's 10 iterations. And then once it's done that, it releases itself from the J loop, as we can see here. J gets set back to 0 because we have entered the for loop again as a new kind of iteration of this for loop. But this time I is 1 because we reached the top, and again I is 2, I is 3, all the way through the J's, I is 4. And I've tried to draw some kind of visual representation of that. You can kind of imagine it as every number in I, every number in I has 10 associated numbers with it in this case. Hopefully that can somewhat simplify and explain what's going on here. Again, nested for loops are rather niche, so I don't see too much of a use for them, but I definitely have used them myself, and they definitely do come in handy, and they are definitely used by a lot of other people. So good to know that. The next loop we are looking at is called a while loop. So we will again write some code, and we will break it down and see what's happening. So if I say boolean, or I can have a number called int random num equals let's say 5. Okay, so a while loop. While is true. Print. I'm not in Python. System dot out dot print line. Help. I'm stuck. Okay, so pause the video here. Tell me what you think is going to happen. I haven't given you any context of what while does, but see if you can have a guess as to what's going to happen here. If you said this is going to infinitely print help I'm stuck, then you would be right. Let's take a look at this. Yeah, as you can see, it's kind of crashing a little bit. It's really not great. We can stop that by clicking the stop button there. That exits. What this is it's an infinite while loop, and it can cause issues. As we can see there, this can never be exited because this is saying while whatever statement in here is true, then do whatever's in here. And this is never changed within here, so this is always infinite. We could say then is true equals false. No, not float, false. And what would happen is this would print it one time because it prints it and then it changes it to false. It goes back to the while loop and says, is true? Well, no, it's false. Okay. See, prints it one time. What is another thing that's commonly seen is a kind of comparator in here to say if the statement's true or not. So we can say random num is greater than 7. And you can get kind of like a for loop going on here, and you can say, sorry, if we set random number to 0, and in here we say random number plus plus, like so. What this is going to do is going to say, while random number is less than 7, do this, and it's going to iterate 6 times because it's up to 7. Sorry, that won't work because it's never greater than 7, less than 7. So it'll iterate through 6 times. It'll reach number 7. It's then no longer 7, and then that's it. It's done. So this is kind of like the for loop we've used, but I recommend using for loops for this kind of iteration. But this is just demonstrating what can happen. Help, I'm stuck. Help, I'm stuck. It's really horribly grammatically typed, but that's fine. 1, 2, 3, 4, 5, 6, 7. Yeah, because we started at 0. Okay, so that's 7 iterations there. So that is the while loop. It just identifies whether something in here is true, and if it is, it runs everything in its code block, and then it comes to the top, and again, determines whether that is true or not, and continues until this is no longer true. I guess it is also worth mentioning the switch case statement here in Java. If you've done any other kind of programming language, you'll have probably seen most of what I'm already saying, so bear with me or skip ahead to newer episodes, or just quickly brisk over these and see the syntax. So switch statements are fairly simple. They use the keyword switch. So what we're going to do here is I'm just going to type out some code once again to break down in just a second. So if we do switch day here, like so, then we have code block called case one. We'll say system dot out dot print line Monday. So we can copy and paste this all the days of the week, like so. 2, 3, 4, 5, 6, and one more, 7. Let's get Tuesday, Wednesday, Thursday, Friday, Saturday, and Sunday. And then we need 7 here, because that's 7. And we need also a default. Okay, so in here we have something called a switch statement. This is the syntax for it. You have switch, and then the regular brackets here, and the expression on what we are switching on. This can be this is usually a variable or something that is some kind of concrete data. So it could be a string, it could be an integer, it could be a character, it could be whatever you want it to be. This is just the thing we are analyzing. If you say switch just analyzes this and determines an outcome, a case is just one of the outcomes. So case that day is equal to 1. So basically if day is equal to 1, we're going to print Monday, case that it's 2, Tuesday, case 3, Wednesday, case 4, Thursday, so on and so forth. This default here is a catch-all, so if none of these are met, it will just always default to this. So if we enter a number here and say 1, we're expecting Monday to be printed. It is not. Bear with me. Ah, my mistake. I have forgotten a break in each of these. This just break is a keyword that breaks out of the current kind of statement or loop. We will head into here and do that now. So we are just going to head into all these and do that. Yeah. So we now should, yeah. So Monday. Okay. So again, case is 1, which it is. We would print out 1 day. Break then says don't check for any of these other cases. Okay. If you don't add the break in, it won't work. But if we change this to 4, for example, we are expecting Thursday, which we get. If we enter 11, it should default to not a logical number. And that is how switch statements work. Kind of useful, but also can just use an if statement. And there are probably a few other cases where if statements are better. There are some niche uses for switch statements. I have used them. I have seen them used also. Um, but in kind of like basic primitive data types like this, it's usually best to use an if statement. But this is also fine. So that is a switch statement. That is all the loops we're going to be loops and statements I should mention we're going to be covering today. Thank you for watching. Watch out for the next one where we're going to dive right into functions and what they are, how we can use them, and their uses. On the next one there'll be a fun little project for you to complete at the end, and I will show the solution at the start of the episode after that. So look forward to that. We should soon start getting to much more interesting stuff. We just have to cover the very, very basics here first, and then we will start dealing with things like user input, opening files, things of that nature. So it will get interesting. Just stick with it. Java is quite a verbose and slow language, not like Python, but this is good progress so far if you've made it this far. Don't forget to subscribe to keep up to date with the training, and enjoy the rest of your day.